Hello dear students, so yes, now all of you are in the verge of pre-board examination, right? So many of your pre-board examinations are starting and many of you have asked, ma'am, please give some most important topics from all the chapters so that we can complete the syllabus quicker and in a smart way. So yes students, here I am with this video where I'll be talking about all the important topics from all the 10 chapters of chemistry. So yes, so you have to note down these important topics. You have to complete these topics at any cost. Okay, so this is not like I'm covering everything, but yes, these are the most important topics. So if you are covering these topics, then you will be able to solve, I guess, 70 to 80% of the questions. Okay, so please make sure that you are completing these topics. So make a note of this. You can take a screenshot of this and put these topics, and once the topics are done, put a tick on that yes, this topic is done, this topic is remaining, and prepare accordingly. Okay, so this can be a checklist for you where you can see that all the important topics you have covered or not. Okay, so yes, now if you are ready with this, let's get started. And the first chapter we have is the solutions, right? So under solutions, first we have Henry's law. Okay, so what all things you need to study in Henry's law? First of all, you need to know the statement. Okay, so please make sure that you learn the exact statement given in NCERT, and you should be knowing its equation. Okay, and the terms in the equation, what does the different terms stand. Apart from this, you should know the application of Henry's law. Okay, and then you should know the relation between KH and solubility, that is inversely proportional. Okay, these are the things about Henry's law. Next, Raoult's law. Raoult's law, you should be knowing the statement, formula, okay, and then numericals. Clear? Next, we have difference between. So what all difference between you should be knowing? So these are the things from where the difference between questions can be asked. Ideal and non-ideal solution, positive and negative deviation, maximum and minimum boiling azeotrope. And you should be focusing on graph of what? Ideal solutions, and graph of positive and negative deviation. And very critical here are the examples. Okay, so examples are very confusing. I also get confused so many times. So please make a proper table and learn all the examples for ideal, non-ideal, positive, negative, maximum and minimum boiling azeotropes. Okay, and once this is done, the major part of this chapter is your colligative properties. So you have to practice numericals from here. At least each type, like 4 colligative properties are there, they are numericals, you should practice. And after this, if you are done with this one, then lastly you can just cover the Van 't Hoff factor. Okay, so these are the important topics from this particular chapter. Now moving towards the second chapter, that is electrochemistry. So the first thing that you should be doing is Nernst equation. How to so what you should be knowing, how to write the Nernst equation. Okay, and you should be solving some numericals from here. Okay, next we have Gibbs free energy. There are two relations here. What is that? Delta G is equal to minus NF E naught of the cell, and delta G is equal to minus 2.303 RT log K, right? So these two equations you should remember. Okay, next we have Faraday's law, the statement. Okay, for Faraday's first law and Faraday's second law statement you should be knowing, and you can solve numericals from them. Okay, and here I'll be telling you numerical mainly from first law is asked, so focus more on the first law first, the numericals of the first law, and then if you have time, go for the numericals from the second law. Okay, but generally first law numericals are more important. Coming to next, we have conductance of electrolytic solutions. So here a lot of formulas are there. So what all things you need to revise? First you should know the formula of kappa, that is sorry, one second. Oh, sorry students, let me just. So from Nernst equation, as I told you, you should be knowing the equation and numericals, right? And then from Gibbs free energy, two equations, delta G is equal to minus NF and E naught of the cell, and delta G is equal to minus 2.303 RT log K. Okay, next coming to Faraday's law, both the first law and second law statement you should be knowing. And for numericals, okay, so prioritize the first law numericals, means you give more importance to the numericals from the first law, and once that is done, you can go for the numericals of the second law. Next, coming to the conductance of electrolytic solution. So here what all things you should remember. The first one is the formula of lambda m, that is kappa into 1000 by C, this formula. Then you have the formula of kappa, right? So we know that R is equal to rho into L by A, right? So 1 by rho will be equal to 1 by R into L by A, right? So these two formulas are important, and you should be knowing how to calculate kappa and how to use that to calculate molar conductance. After that, what all things we have? Here are some definitions that you should be knowing. Kohlrausch's law statement you should be knowing. Then fuel cell. For fuel cell, what all things? For fuel cell and SHE, okay? For these two, you should be knowing the diagram plus reactions, okay? Anode and cathode reaction. Then what is the definition of limiting molar conductivity? After that, you have products of electrolysis, and from the commercial cell focus on the lead cell. And one more very important question is there on this one: effect of concentration, effect of dilution on kappa and molar conductivity, okay? Sorry, effect of dilution on kappa and molar conductivity. So you know, one increases, one decreases, and in molar conductivity also you have the effect for strong electrolytes and weak electrolytes separately, okay? So focus on these areas preferably, okay? Products of electrolysis, especially for NaCl, you should be knowing under molten NaCl and aqueous NaCl, okay? Next we have chemical kinetics, okay? So the first one is your factors affecting the rate of the reaction. So here you know there are three factors. First one is your concentration, temperature and catalyst, right? So and you should also be knowing here about average rate and instantaneous rate, how to calculate, and how to write the differential rate law, okay? Next we have integrated rate law. Derivation is a must, so you should be knowing the derivations for 0th order and 1st order, and for the gaseous phase, okay? These two derivations you should be knowing, and numericals also you should be preparing from these particular topics. After that we have half-life method, so do questions from numericals here, okay? This is very important. After that we have Arrhenius equation. Here also graph is important plus numericals, okay? And yes, for integrated rate law also you have to focus on the graph, okay? Next we have catalyst. So here just prepare the graph. This is very important graph from this chapter. And next one is your collision theory. You should be knowing the postulates, okay? And next thing is Boltzmann curve, okay? So these are the things that you need to focus from this particular chapter. Now moving forward towards inorganic chemistry in D and F block, the first go and study why the transition elements have catalytic activity, color, interstitial compounds and magnetic behavior, okay? So for that, and before starting this chapter, something that you should be knowing is scandium to zinc electronic configuration, okay? After this we have preparation of KMnO4 and K2Cr2O7. This is very important, a must question. Write these reactions 5 to 10 times and prepare them thoroughly, okay? After that you have lanthanide contraction and the consequences. You should be knowing the cause of lanthanide contraction, definition of lanthanide contraction and the consequences of it. Next we have actinoids contraction. So what is actinide contraction and why it is difficult to study actinoids, okay? Reactions of lanthanides and actinoids are not very important, but yes, after finishing this you can focus on that also. And once you are done with these all properties, then go for the rest properties, okay? Okay, so these are the main properties, and then do all the in-text questions of D and F block, very important, okay? In-text questions of D and F block are very important. Okay, now coming to coordination compounds. So here you should be knowing how to draw the VBT, how to write the explanation of the VBT for these four compounds: COF6, UNH3 6, NiCl4 and NiCN4, okay? Next we have here d orbital splitting for octahedral and tetrahedral, and you should also be knowing the electronic configuration, right? electronic configuration for strong field ligand and weak field ligand. Okay. Next we have Werner's theory. Okay, next we have Werner's theory. You should be knowing the postulates of Werner's theory. Okay, and then you should be knowing metal carbonyls. Okay, so Werner's theory, primary valency, secondary valency you should be knowing, and metal carbonyls. Okay, after that, so in metal carbonyls you should also focus on the diagram. Okay, this is more important than the explanation. Then nomenclature, very important, definitions, homoleptic, heteroleptic, chelating ligands, ambidentate ligands. So these all definitions are very important. So I'll just make a note of definitions that you should focus on: homoleptic, heteroleptic. Okay, next you have chelating ligands, then ambidentate. Okay, next what we can have, yeah, these are the most important definitions according to me, so focus on this. And lastly we have isomerism. This is super important. So all the four that is your structural isomerism, their definitions, okay, with examples. So examples are very important, because here examples you cannot create by your own. You cannot just take any metal with any ligand. So you should make sure that you have remembered at least two examples from each of these. Okay. Next, moving towards organic chemistry, the first chapter, haloalkanes and haloarenes. So we have SN1 and SN2. This is very important question. So you should be focused on the mechanisms of both of them. You should be knowing the order. Like for example, in SN1 it is 3 degree, 2 degree and 1 degree, and for SN2 it is 1 degree, 2 degree and 3 degree, right? So here compounds may be given, like there will be a reaction, 3 compounds will be given which will be reacting faster through SN2, which one will react faster through SN1. So ordering type of questions can also be asked from here. So mechanism is super important. After that, this question, haloarenes are less reactive to nucleophilic substitution reaction. What is the reason for that? This also you should be knowing. That is your hybridization, first one, and second one is resonance effect, right? And third one is also there, instability of phenyl cation, right? Instability of phenyl cation. Okay, so these are the things that you can do. Next, coming to the name reactions of this chapter. So Schwartz reaction, Finkelstein reaction, Woods reaction, Wood-Fittig reaction and Friedel-Crafts reaction. So in the name reaction there are two things. First one is your statement, second one is your example. Okay, so every name reaction will carry 2 marks, and this one should be written in this way: first statement and then example. Okay. After this we have some definitions that you should focus on from this particular chapter: racemic mixture, enantiomers, stereocenter or chirality. Okay. Next you have nomenclature, and after that you should be knowing certain definitions, like these all definitions that you should be knowing. Okay. Next we have isomerism. So here also isomerism about, so okay, this isomerism is from the previous one, okay, from coordination compound, so that's not required. Okay, so these are the things that you need to focus. After that, here I will write about polyhalogen compounds. Okay, so just briefly know about the polyhalogen compounds, especially DDT, its structure. Okay, so briefly just give less time for this and complete this one. After this we have alcohols, phenols and ethers. So there are 3 mechanisms in this particular chapter that you should be knowing. What are the 3 mechanisms? First one is your catalytic addition of water to alkenes. Okay. Second one is your dehydration of alcohols. Now see, these 2 reactions are exactly opposite of each other, so many of you might get confused. So it is my request that each mechanism you should write 5 times. Okay, first time you write by seeing the book, second time you write down and check it, third, fourth and fifth please write down without seeing anything, without referring to anything. Okay. Next, third one is what? Third one is your preparation of ether, mechanism of preparation of ether. Okay. Next one, we have 3 mechanisms. Then we have name reactions in this chapter. So Williamson ether synthesis, this is very important, Coles reaction, Cumin process, then aniline and Raymer-Tiemann reaction. Okay. Next we have here Lucas reagent. Okay, so how to test the different types of alcohols and what is the role of Lucas reagent in that you should be knowing. Then the reagent copper at 573 Kelvin. Okay. Next, acidity order, definitely a must question for alcohols. Here you should be knowing that electron withdrawing group will increase the acidity and electron donating group will decrease the acidity, right. Next is so acidity order especially for phenols will be asked, okay, generally. Next, reactions of phenols and anisole. Okay. And one more thing that is very important which I will mention here in ether. Okay. So ether reaction with HX. Okay, this is super important, students. I don't know how I missed it here. This is super important. Okay, so you should be knowing where the cleavage will take place, what mechanism follows, if it is tertiary, if it's primary. So if you want a detailed video on this, or if you have any doubt in this particular concept, please comment down. I will definitely take care of it. Okay. Next, we'll go to aldehydes, ketones and carboxylic acid, the very important high weightage lengthy chapter. Okay. So here first you should be focusing on the nomenclature. Okay. Next, we have acidity order. So because carboxylic acids are there, so definitely acidity order of acids are most probable question in this particular chapter. Okay. Next, you should be knowing the reactions with ammonia and its derivative. Okay, that table is there, right? Hydrogen, carbazide, then hydroxide. So many reactions are there. So please prepare that and focus on the terms that is used. Okay, carbazone, semi-carbazone, what is the name of the product, what is the name of the reagent, that all things you have to do. After that, you have nucleophilic addition mechanism. So in this chapter you should focus on one mechanism, that is nucleophilic addition mechanism, and especially addition of, which mechanism especially is asked is addition of HCN to carbonyl groups. Okay, this mechanism you should prepare thoroughly. Okay. Next, we have reactions of, okay, so this is also not relevant here, sorry. Okay. Now we will, so now this chapter has the maximum number of name reactions, so I will be giving you the list of name reactions in this particular chapter. Okay. So you can focus on Rosenbaum reaction, Stefan reaction, Itard reaction, then Clemenson, Wolff-Kissner, Aldol, Cannizzaro, haloform reaction, Raymer-Tiemann, Gatter-Koch, HVZ reaction. Okay, haloform is repeated, decarboxylation, Tollens reagent and Fellings reagent. Okay, apart from this, if I have left any other name reaction, please comment down, students, but these are the main name reactions that you have to follow. So please remember their, what I'll tell, please remember their statement and the example. Okay. Next, moving towards the last organic chapter, that is your amine. So this is a very small chapter and easy chapter, I guess. So first one, focus on nomenclature. So amines nomenclature is little bit tricky because we have here primary, secondary and tertiary amines. So focus on that. Okay. Next, you have basic order. Okay, so basic order of aqueous phase and in the gaseous phase. Okay, so I'll be telling you, and you should also be knowing the reason for that. Okay, so also the explanation should also be studied properly. Okay, so let us quickly revise that. In gaseous phase, what is the order of basicity? 3 degree, 2 degree and 1 degree. In aqueous phase, order is 2 degree, 1 degree and 3 degree. If the R group is methyl, right, and if the R group is ethyl, okay, then it is 2 degree, 3 degree and 1 degree. Okay, so you should be knowing, the question may be asked like why it is like this, so explanation should also be learned. Okay. Next, you have preparation and the chemical reactions of amines. Okay, and then you have reactions of diazonium salt. This is very, very important. So any conversion questions from this chapter will be based on this one. So make sure that you have learned all the reactions of diazonium salt. Next, coming to the name reactions in this chapter. So you have Hoffman bromamide degradation, okay, very important reaction. Gabriel thalamide, very big lengthy reaction. And here as reasoning question is also asked that it is only used for the synthesis of primary amines. Why? Okay, so this question also you should prepare from this particular reaction. Carbyl amine test, carbyl amine reaction, that is there, and it is also used as a test for primary amines. Okay, next Hinsberg reagent. So you should be knowing how this one can be used to differentiate primary, secondary and tertiary amines. Okay, next we have biomolecules here. Okay, so first of all, in biomolecules you should be knowing about carbohydrates. Okay, so carbohydrates, first thing, glucose structure. Okay, so there were 6 reactions, right? 6 reactions to determine the structure of glucose. Remember, first one was reaction with HI to show that it is a straight chain, all the carbons are in one straight chain. Then you have the reaction with I think oxime, okay, so show that it is having one carbonyl group. Then one reaction to show that it is an aldehyde group. So each reaction can be of one question. Okay, so question can be like this: which reactions, or write the equation of a reaction to show that glucose has an straight chain structure. Okay, so you should be knowing the reaction. Question can be also be like that: prove that the glucose has a straight chain structure. Okay, all the 6 chains are in one straight chain. So you should be knowing those reactions. So you should be, for these 5 or 6 reactions, you should be knowing the reaction, and second very important is the conclusion, means what that reaction tells you about the structure of the glucose. Okay, that is very important. Next thing is disaccharide. So 3 disaccharides are there, that is your lactose, sucrose and maltose. Sorry, not maltose. Sorry, lactose, sucrose and galactose. Okay, so in each of these 3 you should be knowing the structure. Okay, you should be learning their structure and the carbon-carbon bond, the glycosidic linkage between these 3 structures should be very clear. Okay, and I know it is little difficult to remember the structures, but yes, you have to practice it again and again. Okay, and next coming to polysaccharides. In polysaccharides, what you should be knowing, the same thing, there are 3 polysaccharides: starch, right, glycogen and cellulose, right. So you should be knowing about their structure, and in starch there is something you should be knowing about the difference between amylose and amylopectin. Okay, so in polysaccharides diagram is not needed, but yes, you should be knowing the linkage, glycosidic linkage you should focus on. Okay, next we have here protein. So under protein you should be knowing what is the structure of primary, secondary and tertiary proteins, their definitions. And in the secondary you have alpha and beta, alpha helix and beta pleated sheets, right, alpha helix and beta sheets. And after that in tertiary you have the difference between fibrous and globular proteins, right. So these all things you have to study in protein. Next coming to vitamin and their deficiency diseases, this is super important. It can be asked in any MCQ, it can be asked as a 1 marker question. Many possibilities are there that you should learn this one. Next, different hormones and their functions. Okay, but this is less important, but this is very important. Next coming to nucleic acids. So you should be knowing about like what is a nucleoside, okay, what is a nucleotide, what is the difference between these two, then what is the difference between RNA and DNA. Okay, so these are the things that you have to focus on. Okay, fine. Now after this, okay, that's all in this, students. So these are the major important topics from all the chapters that you need to focus. And if you want any like discussion on any particular chapter or any particular topic, please comment down. I will definitely clear that concept for all of you. Okay, so thank you students, and see you soon next. And if you found this video helpful for your pre-board examination, do not forget to subscribe the channel. Thank you.